In this animation, we will investigate testing for positively charged ions. We will use precipitation reactions to identify positively charged ions, which are called cations. In these three tested tubes, we have copper 2 ions, iron 2 ions, and iron 3 ions. We will add sodium hydroxide solution to each of these tested tubes. Let's start with the tested tube containing Cu2 plus ions. We will add and shake. A light blue precipitate is formed. So when we add sodium hydroxide solution to a solution of metal ions and we observe a light blue precipitate, this means that we have copper 2 ions. Let's add sodium hydroxide solution to Fe2 plus ions. A dirty green precipitate is formed. On the other hand, when we add sodium hydroxide solution to Fe3 plus ions, a rusty brown precipitate is formed. So to differentiate between Fe2 plus ions and Fe3 plus ions, we will observe the color of the precipitation with sodium hydroxide solution. If it's dirty green precipitate, then this is iron 2 ions, and if it's a rusty brown precipitate, then this is iron 3 ions. These are the ionic equations for copper 2 ions reacting with an alkali. Cu2 plus, which is aqueous, plus 2OH minus, aqueous as well, will produce CuOH2, which is solid. For iron 3 ions, we get Fe3 plus ions plus 3OH minus will produce FeOH3, which is solid. By examining these two ionic equations, select the option below that completes the ionic equation for the test of iron 2 ions, Fe2 plus 2OH minus. Let's use the crisscross method. The 2 will be over here and this one over here, so this is FeOH2. The product is FeOH2, which is solid. Match the metal ion to the color of its precipitate formed with sodium hydroxide solution. We have copper 2 ions, iron 2 ions, and iron 3 ions. Examine again this figure and write down the answers. With copper 2 ions, we have a light blue precipitate. With iron 2 ions, we have a dirty green precipitate. And with Fe3 plus ions, we have rusty brown precipitate. So you must remember these colors. Copper 2 ions will produce a pale blue precipitate, iron 2 plus ions will produce dirty green precipitate, and the rusty brown precipitate indicates the presence of iron 3 ions. Aluminum, magnesium, and calcium ions form precipitates with sodium hydroxide solution. The only problem is that all their hydroxide precipitates are white, so we cannot differentiate between them. To distinguish between the three ions, we have to do further tests. Aluminum hydroxide dissolves in excess sodium hydroxide solution, while magnesium hydroxide and calcium hydroxide do not. So this leaves magnesium ions and calcium ions, and then we will use a flame test to tell the difference. This is a nichrome wire, which is dipped in a calcium compound. We will observe the color of the flame. A calcium compound turns the flame brick red. Let's examine the magnesium compound. The magnesium compound has no effect. So again, calcium will produce a brick red flame, whereas magnesium has no effect on the flame. Here are some other flame tests that we can use to identify other metal ions. Let's start with lithium flame test. So notice the color of lithium. The flame is red. Let's examine sodium. So this is the color of flame when using sodium. It's a yellow flame. What about potassium? Potassium produces a lilac flame as shown here. And finally, let's examine barium. Barium will produce a pale green flame. Let's match now the metal ion to its flame color based on your observations. What's the color of the flame if we have lithium, if we have sodium, if we have potassium and barium? Excellent. So if we observed a red flame, then this is lithium. A yellow flame indicates the presence of sodium. Potassium will produce lilac flame, and barium will produce an apple green flame.